Today, we are going to start with quantitative analysis. Is the topic of discussion. So before we proceed to this, let us start by defining what quantitative analysis is. Quantitative analysis deals with measurement of what? Volume and mass measurement of what? Of a given sample. So actually, in chemistry, analysis is very important. In fact, it is the backbone of chemistry. So without analysis in chemistry, you are nowhere to be found actually. So today we introduce this, and we introduce some part of the apparatus that are used in carrying out all this analysis. As we said earlier, it deals with what? Volume measurement. So among the apparatus, we have the measuring cylinder. This is called the measuring cylinder. It is used for what? For measuring reagents. This one also is a measuring cylinder, but different graduations. This is 100 mils graduation, and this is what? 500 mil graduation. We have our retort stand. We have our burette for adding either acid or base, depending on the type of titration you are taking. And we have the what? The pipette for what? For pipetting out either base or acid, depending on the analysis to be taken. Then this is our conical flask. This is our what? Beakers. Mostly these two serves as container, but they are also sensitive. So when carrying out titration, first of all, there are some precautions to be taken. So precisely, you need to wash all the what? You need to wash all the apparatus before what? Before you start the analysis, in order to what? To prevent what? Contaminants. And we have so many precautions also to be taken. So let me show you how to set up the apparatus. So this is our clamp. The clamp will hold the burettes. So you clamp the burette into the clamp holder. Then you are not going to press it much because this is fragile. It's going to break. Then this one, you have to add your what? Your acid. So we said today's class is an introductory class. So I will just show you how to make the setup. Then if you are titrating, for example, you are titrating acid against base, then the acid will be added into the burette. And if you are titrating base against acid, then the burette will contain the what? The base. So that's the difference between the two. Then the pipette, if you are now titrating acid against the base, you are going to pipette out the base using the what? The pipette. So mostly this is beaker, a container. You either add base or acid to it, and this one, after pipetting, if you are pipetted out base, then you have to add it into the what? The conical flask. Then the setup, you will what? You will now start to release. Sorry, after pipetting out the base, we add what is known as the indicator. You add in your indicator 2 or 3 drops into it for what? For color changes. It will change the color. Then at the end of the what? Reaction also, the color will also change. So that's basically the usage of this indicator. And this is the wash bottle. You all know the usage of this for what? For washing all the what? Utensils before the apparatus. And we have what we call the white tile. So the white tile is usually placed here. Why is the white tile being placed here? Is to what? To be sensitive of the color change, because without the white tile, if you leave it like this, maybe the color will change and you will not be able to know precisely at which very point does the color changes. So that's why we add a white tile to it, so that because it is white in color, the changes will be precisely, because each drop is almost 0.2 here. So it's going to change your result. So, and after that, we have what we call the table. You are going to what? Record the table. So this is just a sketch of how the tables look like. So we have what we call the first reading, all in same cube. The second reading in same cube also. The third reading all in cm cube. Then we have we call it here readings. This one the final, let's say the initial reading, the final reading, and the what, and the volume of acid used. So how do you obtain all these values? Well, we say the initial value is the what? Is the value obtained from the burette before the titration. Before what? The titration. So, for example, if you are starting the titration at 0, maybe the initial here will be what? 0.00. And after there is any color change in the what? In the basic solution here, then that's your what? Your final volume. Maybe you have started titration at 0 and at 5 or 6 the color has changes. So let's say 5.00, the color has changed. Then the volume of the acid used will be what? This final minus the initial. This what? Final minus the initial. So what is 5 minus 00 is the same that 5. So you follow the same procedure of the what? Of the steps in taking out the titration to do like 3 or 4 times to have a what? To have a value that is what? They are more closely related, known as what? A concordant value. Known as what? A concordant value. Okay, so that is that for the table. As we have said earlier, today's class is an introductory class. So when we meet next, we are going to elaborate more on this. So any question? Any question? Or I should ask my question before we proceed. We said concordant value. When is a value said to be concordant? What is a concordant value? Or what are the precautions to be taken when handling this our apparatus? You see them, they are all glass and the rest. You want to say something?
Make sure you wash before and after using.
Okay. Any more idea?
Never touch, smell, or taste any reagent.
Okay, as I was saying, when is a value said to be concordant? Any idea?
Yes. Concordant value refers to the value in agreement or harmony with one another.
Okay. So, but at least there are some difference. Who can tell me the difference between the two, or the more values? What is the relationship between them?
Minus 0.2.
Okay. Any question from your own part? Okay.
How many concordant are there in ventilation?
So it depends on the table, or we can say one. For example, let's use the table we have here. Now that this is a sketch of the table, we have 5 here, for example, and this one, let's say the second one initial is also 0.00. Our final, let's say 5.0, let's say 2. Then if you minus this from this, you are going to obtain 5.02 as well. Let's move to the third table. Let's say here we started at 5.02, and at the end of the titration, we are able to obtain something like 10 point, let's say 04. So we are going to minus this automatically, right? 10.04 minus this, you are going to obtain 5.02. And we said a concordant value is a value with different, not more than what? Plus or minus 0.2. So look at this. What's the difference between this and this? Plus 0.2. This and this, 0.2. So you can pick either of the two, or you pick all. So as I've told you earlier, so for now, for this table now, all the values are concordant because the difference does not exceed what? Plus or minus 0.2. Okay, before we call it a day, let me ask more questions. So what is the importance of this volumetric analysis or quantitative analysis that we have been talking about? Any idea?
Yes, sir.
Okay.
It enables the chemist to calculate the non-quantity of the materials.
Okay, non-quantity of materials to be used.
Yes.
So this is a very good, important, and added to that, it has so many variety of uses in both our industrial, so many. In fact, even in our day-to-day activity. So in conclusion, basically, A chemist without the knowledge of qualitative analysis or quantitative analysis is not a chemist, rather a quack chemist. So please, before the next class, go and what? Elaborate more on this. When we meet again, we are going to say one or more things before we conduct our real practicals. So see you next class.